Okay, factorization identities. Going back to these sine and cos addition identities. Okay, everything in this section goes back to these equations that we came up with, and this is even how we got the tangent x plus y, tangent x minus y. So you have to remember these equations. And earlier we looked at if x and y are the same, if it's x plus x. Okay, so you can use these equations simply enough, if you've got something like sine of 75, you make it sine of 45 plus 30, and you use the equations going this direction. Okay, you've got on the left side, so you use the right side to get an answer. Okay, but you can also go the other way. Okay, you can go away. You get something on the right side and you go backwards. Okay, which we did earlier in an example where we had find sine of pi over 8. Okay, sine of pi over 8. Let me pull that over here. Okay, so what I did with that one, if you remember, is we put this into the right side of the equation. So x was pi over 8. Okay, and so what we did is found, okay, well 2x is pi over 4. Again, pi over 4 we knew. So to find pi over 8, we used the equation backwards. Okay, it was an example we did earlier. So now in this section, we're going to do it. Similar thing, but something like, one of these. We might have, well, let's look at our first example. What is our first example? 2 sine 5x cos 2x, okay? 2 sine 5x cos 2x, okay? That's what we're gonna do. We're going to use one of these right-hand things and get back to the left side, okay? So we need to come up with a couple of new formulas, okay? So what we can do is if we take equation 1, for example, plus equation 2 up here, let's add our two sine equations. X plus y plus sine of x take y. Okay, if you look at these two here on the right, obviously this and this are going to add together. So I'm going to get two of those, 2 sine x cos y. And these other two over here, they're going to cancel out. Okay, so we can actually have a nice expression for, let's put it this way. We'll divide by 2. Let me switch it over here. So sine x cos y equals sine x plus y plus sine x take y over 2. Okay, and if you do some more of these, if I took equation 1 and I subtracted equation 2, if I took 1 minus equation 2, it's going to double up these, okay? It's going to be minus a minus of those. So I'm going to get cos x sine y equals, and on the right side, on the other side, that's when I'm subtracting. I'm doing 1 minus 2, so that's going to be sine x plus y take sine x minus y over 2. Okay, so I can do the same with these cos equations. I can add them. 3 plus 4. So if I add 3 and 4, obviously these are going to double up and these are going to cancel. So I'm really going to get a formula for that. Cos x, cos y. So it's going to be adding them up. Cos x plus y plus cos x take y, and because I've got 1, 2 of them, I've got this to divide by 2. Alright, and again, oh crap, this is, okay, and again, subtract them. Cos, well, no, we're sine now, aren't we? Yeah, if I subtract them, let's see here. I'm going to have to do 4 minus 3, aren't I? Otherwise I'm going to get a damn negative. So let's do that way. Let's do 4 take 3. So that's going to give me sine x sine y equals, that's going to give me, yes, cos this x minus y first, and x plus y second. Okay, so let us put these into use somehow. So here we go. We have this sine of 5x cos of 2x. Now it's a bit confusing here because we got all these x's, and this is not, these x's are not the same as these x's. Okay, I mean, these could be a's and b's. Okay, it's just recognizing that this formula here, sine x cos y, so we're using this one. Okay, sine x cos. So we've got 2 sine 5x cos 2x equals, so we've got 2 times this, the 2's are going to cancel out, yeah? We've got this 2, I'll just put it down 2 to start with. Okay, so I got sine of, okay, now instead of x plus y, it is, well, there's my x, there's my y, it's 5x plus 2x. And instead of x take y, it's 5x take 2x. And then it's that whole thing divided by 2. Yeah, because that's in the formula. Okay, so we get 2 sine 5x cos 2x equals, the 2's are gone, sine 7x plus sine 3x. Okay, so we get, and that was what the question asked, as a sum or a difference. To write this as a sum or a difference, well, that is a sum. Yeah, okay. Alright, that was the first example. We've got a couple more. Actually, we've got 3 more because there's like 4 different types here, so. Okay, the cos one. Okay, the cos one is, let's see, the double cos. That's the double cos. So it's going to be cos of x plus cos of x minus. Okay, so there's my pretty straightforward. Cos of 3x cos of x equals cos of x plus y plus cos x minus y over 2. Now remember, that is my x from my formula, that is my y from my formula. So we get 3x plus x, 3x minus x. So we get cos 4x plus cos 2x over 2. Capiche? Okay. Next one, 5 cos 4x. So cos and then sine. Which, I mean, really, cos and then sine, I mean, it doesn't matter. You can put them really either way there in that formula, but we'll just go with, since cos is first here, let's just do it this way. Otherwise it gives us a minus. Anyway, cos, sine. 4 formulas, cos, sine. So let's do this one. It's the minus, okay? So, 5 cos 4x sine 2x equals 5 times, what's that one again? Cos and sine is sine plus minus sine minus. Sine of 4x plus 2x minus sine 4x minus 2x over 2 equals 5 over 2 of sine of 6x minus sine of 2x. And there we go. It's a sum or a difference. And last one, it's a sine and a sine. Let's see, the sine and a sine. So that's cos of the minus minus the cos of the plus. Okay, that one. Okay. So equals what did I say? Cos of the minus, right? Cos of 3x minus x minus cos of 3x plus x all over 2. That's a terrible 2. Alright, cos 2x minus cos 4x over 2. Does that make sense? Let's see. Cos of minus minus cos of plus. Yes. Okay, all done.